So it gives you 60 grams of P4, 82 grams of O2. Now, in this problem, you don't know where to start now, at least not initially. Now, I guess which one would you think, just based on this, is going to run out first? Which one seems like it should run out first?
60 grams.
I mean, you'd think, well, you'd think the one that, like, is smaller, right? That's your initial thought. But that is not the way to go. Because look at the reaction.
What?
If you look at the reaction, it takes 5 O2s to combine with 1 P4. So the point is that, you know, it takes a lot more oxygen than it does P4 to have this reaction go. But the point is, like, it's not really something you're going to be able to figure out off the top of your head. Like, you look here and there's just no way to know. I mean, even when I wrote this problem out, was not sure which one it would be until you do the calculations. So, the way you're going to do this, all right, there's several steps. Now, the first step is to just find the limiting reactant. All right, now that requires several little parts to it. So, part 1. What do you think we should do? The same thing we've done always for every problem ever, basically. What should we convert to? Convert the values to moles. So, convert to moles. So the way you will do that, you'll take 60 grams of P4 and you'll convert that to moles. Now that's 1 mole, and then this is a mistake that a lot of people make with this type of equation. It's phosphorus, but there's 4 of them. I mean, like, a lot of you in your work have already done, you know, where I've seen you write 30.97 instead of that times 4. So remember, phosphorus is 30.97, multiply it by 4. And that ends up being 123.88. So you do this math, you end up with 0.484 moles of P4. Now again, notice how neat I'm writing also. This is important. Yeah. Now next, you do the same thing. You've got 82 grams of oxygen. Grams of O2, moles of O2. Now remember, oxygen, you know, 1 mole is 32 grams because it's 16 times 2. Just in case you're forgetting. You know, 16 times 2. That will give you 2.563 moles of O2. All right. Now you get to this point. The next step, all right, the next thing you have to account for, you've got them in moles now. You now have to account for the coefficients in the equation. So here's what you will do. Just like, you know, the next little thing, if you will, divide by coefficients.
This is also finding out the LR.
Yep. I mean, I'm going slow and I'm showing you, like, you know, step by step by step by step. Once you do this, you'll be able to do it quicker. So the next thing you will do, you're going to take your P4. What is in front of P4 here? Nothing, so assume it's a 1. All right, that gives you, you know, 0.484 moles of P4. Nothing changes. Oxygen, though. What's in front of oxygen?
5.
It's a 5. So divide by 5. That gives you, what was it? No. 2 divided by 5 is not 12. Oh, so I should. Yeah, I am. The microphone can't pick that up, thank God. Now, so what did I divide by? Is that what we just said?
Is that 0.484?
Hang on, what?
So you got the 5 from the equation?
Yeah, so since this was O2 and it had a coefficient of 5 there, that's where it came from. All right, now you can actually determine the limiting reactant. Now you look at it and you say, okay, I've converted to moles, I've accounted for coefficients. You look at it now and you say, okay, what is limiting reactant? Well, which one is now the smallest number here?
P4.
So P4 is smallest. It's actually really close, but P4 is smaller. And that now you've identified, you say, okay, this is the limiting reactant. All right? So you would say you can make just a little note. The smallest thing, I mean, it's kind of obvious, is the limiting reactant. All right, so in this example, P4 is the limiting reactant, and that makes the oxygen, it didn't specifically say to do this, but that makes the oxygen excess. Now, once you get to this point in time, you have to remember that the question did not want you to do this. The question did not in any way, shape, or form mention what is the limiting reactant. It just said how many grams of P4O10 is made. It doesn't care about anything else. So, you now have to go and do the problem. So do the actual problem. So since step 1, that implies there's a step 2. So step 2 implies now, it just says, do the problem. In this case, it's a mass-to-mass problem. So what you will do now, we identified that P4 was limiting. So we will do 60 grams of P4 and we will convert it to grams of P4O10, which is exactly what we've been doing for quite a while. All the same mass-to-mass stuff now. So you'll start out, you'll do 60 grams of P4, grams of P4. Now, I realize if you are if you're on top of this and you get everything that I'm showing you right now, then you will realize that you will already have done this part of the conversion already. So if you want to just take this 0.84 or 484 moles of P4 and just start and skip this little bit here in this step, you can. But if that doesn't mean anything to you and you don't even know what I'm talking about, because I'm just do it like this then. All right. 123. The periodic table. So you're just going, now 60 grams of P4, you're going to convert it to grams of P4O10. So you convert to moles, then moles of P4, moles of P4O10. So remember, this first step, that's from the periodic table. These now, we need our coefficients from our equation. So P4O10 and P4. What's in front of both of them right here? Nothing. So it's a 1 for each. That's really nice and simple. What?
So why wouldn't you, I get the limiting reactant on that, but why wouldn't you just add the 2 grams up? Why wouldn't you just add 60 and 82? Because that's what makes the P4O10.
Because the point of it is that not all of the excess thing is used up, so you can't do that. If it was a perfect reaction where the exact quantities combined and were all used up, then you could do that. Okay. But it's never going to be like that.
How are you going to know? How would you ever know?
Well, you have to figure it out. And if you found that they both the mole ratios were perfectly the same.
So if they're both 513 or 0.
Sure, yeah. If it worked out like that, but it's seriously, it's never going to.
Okay.
All right, but if it did, yeah, sure, that'd be fine.
Right.
What? You're saying what?
Oh, I was going to ask you, so if you skip that first part, we have just put the moles up there. So the next part you still have to take from the periodic table?
Yeah. No. So you would basically be you'd be starting right there, basically. All right. Except instead of 1 mole, you'd have the 0.484.
All right.
Now, the next part, you do grams, P4, O10, and this number will come off the periodic table. It's going to be 4 P's, 10 O's. It's 283.88. So again, all you do there, you just you add 1 P, 4 P's, 10 O's. You've done it a lot.
Wait.
What?
Oh, never mind.
What? Where did I get what? That's just it's 4 phosphoruses and 10 O's added up their masses. So you do all the math, you end up with 137.5 grams P4O10. And that is the answer to the problem. I know. An entire page.
Oh, it's happening.